will help instigate a clean environment transformation in Asia. Today, we aim to get another step closer to it through the launch of our quarterly newsletter, Prakriti. I welcome Professor Liji Philip, Professor Shiva Nagendra, and all other experts, dignitaries, and participants to the event. Now I invite Professor Shiva Nagendra, CEPHA Network Director, for the official welcome address. Sir, please.
So good afternoon to all of you. It's a great pleasure in welcoming Professor Liji Philip, a chair professor in the Institute Chair Professor in the Department of Civil Engineering and Dean Planning, IIT Madras. She is the fellow of National Academy of Engineers and also fellow of Royal Society of Chemistry. She has, we're fortunate. I've been to work with her for more than 1 decade in several projects. She has contributed immensely in advancement of environmental engineering in the country, and also developed several technologies which will be beneficial for the society, in particular the rural areas. Our quality of research, in terms of addressing some of the key areas like industrial effluents from highly polluting industries, bioremediation of contaminated soil, groundwater. So she has developed several novel processes in addressing many of the polluting industries issues. So we are, and also she is a very active and also supportive towards many NGOs and also many organizations in conducting and organizing many environmental related issues. Of course, she is an expert and guiding many international agencies, reputed international agencies such as Bill Melinda Gates Foundation, and also she is member of many committees like NGT and Tamil Nadu Pollution Control Board, Kerala Pollution Control Board. Almost all pollution control boards are expertise being, seek. With this, we have a great fortune and to request Professor Liji, and we are launching this newsletter. And I also welcome all other participants, expert members working in the various areas of environmental engineering. Now I'll request Professor Liji to launch our newsletter Prakriti. Professor Liji.
Thank you very much, Professor Nagendra, for the nice introduction. Though I won't deserve it. Okay. So, dear distinguished guests, my dear students, ladies and gentlemen, a very good afternoon to all of you. At the outset, I thank the organizers for giving me this opportunity to be with you on this important occasion of releasing this newsletter, Prakriti, by the Clean Environment and Planetary Health in Asia, CEPHA network. This itself is a very good initiative and need of the day. One cannot overemphasize the importance of air quality and its importance to the survival of environment and to the survival of humanity itself. Recently published IPCC report has warned about the severity of climate change and how it is going to affect the humanity and other biota. It is our duty and responsibility to protect the earth for the future generations. Pollution is not a local problem, hence there is a need to address it in a global scale. We are aware of long-range transport of air pollutants and it is well documented. Earlier we were thinking that water pollution and solid waste are a local problem, but it is becoming more and more clear that these pollutants are having global implications. We are familiar with antimicrobial genes, antibiotic resistant bacteria, etc. And these are examples of this one. One can find these genes all over the world. So this shows that how global is the pollution impact. Significant quantity of research has been carried out in the last few decades on many aspects of pollution and pollutants, their occurrence, fate, transport, remedial measures, long-term impacts, etc., etc. The research findings has to be taken to a much wider audience, and it is our responsibility to make other researchers as well as laypersons aware of the kind of research and development work that is currently going on and what we have learned so far. We have to share our experience and learning with others. In this context, the newsletter Prakriti is an excellent initiative. I congratulate the team. I am happy to see a group of dedicated, established, and enthusiastic scientists, academicians, and technocrats from many parts of the world is involved in this network. I wish pretty soon CEPHA will become CEPHA, that means Clean Environment and Planetary Health for our Mother Earth, not only restrict to Asia. I officially announce the launch of the newsletter Prakriti by CEPHA, and thank you all.
Yeah. Thank you, Professor Liji. Gopika, can you just show the newsletter? And probably we can take one photo of this one. So.
Excellent.
Mr. Liji, thank you very much.
Yeah, thank you very much. It is very, and really, it came out very well. Okay, so who are the audience? How are you going to publicize it?
So we have, basically we have that CEPHA website is there in IIT Madras. So we are just putting it and then you do email circulation. That is the plan.
Oh, okay. So you wanted to connect to that Dean ACR office. There is some newsletter and all, isn't it? Okay,
Yes,
you can connect with that one also, because that one will be going to the alumni and all also. Okay.
Yes.
So very nice initiative. Very good initiative. Okay. Congratulations to all the team. Okay.
Yeah, Professor Liji, thank you very much. And it was a, I know you are quite busy, but you're taking your time and, particularly we are really fortunate and very happy that this newsletter has been released by you. You are contributing so much for the country's environmental engineering program. So we are very glad and we are very proud of it.
Okay.
Professor Liji, one more request. Maybe probably I will contact one forward message so that we wanted to use that with your permission.
Okay, yeah, we'll discuss about that one. Okay, so I wanted to say that it is becoming a global thing, not only to Asia. Okay.
Yes.
Okay, all the best. Okay.
Yeah,
okay.
Thanks, Professor Liji.
Okay.
So on behalf of
Thank you.
CEPHA, we will thank you all.
Thank you so much. Okay, bye-bye.
Thank you.
Okay.
So now we will go to Gopika. Could you? We'll start. The air quality management lecture series, or should we wait for some more time? Dheeraj, Gupta ji requires some help in sharing the slides. Can you just do it from your side? Or Gopika, can you do it? Any one of you, can you just confirm it? Who will going to do it?
I can share it, sir.
Yeah, you can share it. Okay.
You have received the
Yes, sir.
Yes, sir. Yeah, we have received it. We have received it.
Thank.
So just we will wait for some few minutes or maybe about so we'll another few minutes.
Yeah,
so let's
certainly.
Yeah.
This is the 11th lecture in the series, Dr. Shiva.
Yes, sir. Yes.
So it has been a great effort organizing such a series every month. This means it's almost 11-month-old series now.
Yeah, 11th month old now. And all credits goes to these research students.
Yes, yes, certainly. But your inspiration and your leadership is commendable. And you are certainly doing a human service in this field. I'm sure this is creating a lot of awareness for the people, and it
Yeah,
is strengthening the
hopefully.
scientific understanding of the country.
Yeah.
Which will go a long way actually. Education is a process which definitely shows results after a long time.
Yeah.
Learn and then experience and share. While working, you really recall some of the learnings and try to use them in your work. Definitely helps.
Oh, Gopika Satoris was there. You could not remind me. Professor Satoris, can you just put him in the panelist? Satoris, can you hear me? Yeah, Satoris, I mean, we missed you to comment on the give some vote of thanks to the launch of a newsletter.
Yes, happy to do that. Is that now?
Yeah, maybe we can, since we are doing it the record, maybe you can just comment on that one. So it's okay. I mean, just Professor Liji, she has to attend for another a meeting at 3 o'clock, so she left. So yeah, maybe you can just comment on the newsletter and just thanks to everybody who organized, in contributing that newsletter, particularly Dr. Matsudan, Gopika, Swaroop, who worked extensively in creating this newsletter. Yeah, over to you, Satoris. Then after that, we'll start the air quality management lecture series.
Thank you very much. It's my great pleasure to welcome you all to this seminar organized by IIT Madras, Professor Shiva Nagrenda and his team. I'm from the Australian National University, and I'm honored to co-direct the CEPHA network with Professor Nagrenda and his team. It's our pleasure today to launch the first newsletter of the CEPHA network. CEPHA means Clean Environment and Planetary Health in Asia. It's a beautiful publication, online publication, very environmentally friendly, with articles, editorials, news from the network and more broadly. So I would encourage you to disseminate it widely, and please do give us your feedback on the publication so we can also improve it in the future. I take the opportunity to thank very much Professor Shiva Nagrenda and his team, and the editorial board, Dr. Gupta, the colleagues who contributed to the newsletter, and all colleagues involved in the CEPHA network. Without any further ado, I will leave the floor for the host of the seminar of the lecture today to coordinate the speakers. Thank you.
Yeah, thank you, Professor Soteris. Maybe Gopika, could you just start with a glimpse of the newsletter? Then we will start the air quality management lecture series.
Yes, sir.
My apologies. I haven't acknowledged in name and person everybody who has contributed to the newsletter. I'm very grateful to Gopika and all the team. So sorry, I haven't spelled out all the names.
Yeah. So just to that's why I thought Gopika will just display so that we can.
Thank you.
Thank you, Professor Soteris. Okay, so
Excellent.
thank
Excellent.
you, Gopika and Dr. Madhusudan. Dr. Madhusudan is there?
Sir, he said he's facing some issues, so he's not
Okay.
able.
Okay, so maybe we'll line that by okay. No, so Dr. Madhusudan, yeah, Mr. Swaroop is here. So yeah, thank you all for excellent work for contributing this newsletter. Now over to Gopika, so we can start air quality management lecture series. Gopika, you can start introduce, but then I'll take few minutes to explain about air quality management lecture series, and then introduce Professor Guptaji, Dr. Mr. Guptaji, and then yeah, Guptaji will take over. Okay, Guptika, can I start?
Yes, sir.
Okay. Okay. So good afternoon to all of you. Welcome to Air Quality Management lecture series. Today is the 11th lecture. We started in last year, October 2020. So this is lecture is first of its kind, which serves an important forum for young researchers, scientists, engineers, educators, practitioners to learn latest advancement in theories, technologies, applications in the area of air quality management. So this air quality management series is jointly organized by IIT Madras, CEPHA network, and the Indian International Conference on Air Quality Management. I would like to thank all the experts, support from the various professionals working in different in capacity in successful of this lecture series. So now go to the next slide, Gopika. So we started organizing these are the eminent speakers in the past. They gave in the air quality management lecture series. We started with Sk Gupta ji, and last lecture was given by Professor Karyachat from Thailand. Next slide, please. So today we have a very eminent speaker. Gupta ji is known in the country because of his immense contribution in terms of addressing particularly the air quality issues. I think he is the pioneer. He started air quality monitoring instrumentations more than 4 decades. So I think I'll request Gopika to introduce Gupta ji, and then I'll request Gupta ji to share his long experience, how country has benefited in creating the local technologies of an high end meeting the local requirements and helping in policy framework and health issues. Over to you, Gopika.
Thank you, sir. It is my pleasure to introduce the speaker for today, Shri Sk Gupta. He is a civil engineer from IIT Kanpur and has been known as a person for air quality monitoring and management in India due to his important contributions and pioneering efforts to produce India's own air pollution monitoring instruments in the early 80s. He set up an Envirotech Instruments, a company to produce indigenous instruments like stack monitoring systems and respirable dust samplers for the first time in India. He also set up nearly 100 real-time monitoring stations across India. Currently, he is working with IIT Delhi and IIT Madras to develop indigenous low-cost sensors for monitoring PM 2.5, carbon monoxide and nitrogen dioxide, and with IIT Jodhpur to produce an indigenous odor monitoring device. He has also been instrumental in initiating hands-on training programs in India for field personnel and has organized more than 100 such short courses. He has acquired rich experience in the field of environment by participating in several hundred monitoring assignments, EIA or EMP studies, and design and fabrication of pollution control devices. He is the Honorary Secretary of Indian Association of Air Pollution Control, Delhi chapter, and is also the founding and mission advisor of Global Council Environmental Health. His initiatives and efforts has helped the country to generate data on its own air environment. The talk for today is titled Issues and Challenges in Air Quality Management in India, where he'll be discussing the challenges that are confronting the country in maintaining the wholesomeness of the air quality, highlighting the technical as well as non-technical aspects. He'll be sharing his experience from the field over the last 4 decades and the efforts made by a small private enterprise like Envirotech Instruments Pvt Ltd in monitoring and management of air quality in India. Sir, we welcome you.
Thank you. Thank you. Thank you, everybody, and good evening to all. It's a great honor for me to be seen among the August speakers, last 10 speakers. And I was feeling very proud that my photo will also come as 11th speaker in this series. And I was feeling so elated in my, inside. And thanks to CEPHA and thanks to Professor Shivan again for giving me this honor. And I'll try to do my best to share whatever experiences we have gained in the last 4 decades in the field of air quality monitoring and management. And let me first clarify that I am not an academician, either I am a great professional. I have graduated from IIT Kanpur, learned my education, taken my education from that, and I have very closely worked in this field under the guidance of late Professor D.D. Agarwal, who was a professor at IIT Kanpur of environmental engineering for 17 years, and then later he served as member secretary of CPCB also for 3 years, and then joined Envirotech and established this company as one of the foremost company, which used to be very dependable. Supreme Court used to, I remember 80s, period of 80s, that Supreme Court used to refer to either NIRI or to Envirotech for carrying out reliable monitorings in this country. So that is my background, and I'll now share my experiences by sharing my slides. My first slide, Gopika, would you help me in sharing the slides? Yes. So I have divided my talk into 5 issues. One is I will talk about the concern for air quality in India, how it started, and what were the issues and challenges in the early 1980s when the concern for air quality started. And then I will also briefly talk about issues and challenges which are still confronting the country. And then I will take some time to highlight the efforts made by my company Envirotech, where I work, to address these challenges in the last 3-4 decades. And last May, there will be some suggestions which we would like to give for better air quality management in the country. Next one. Friends, air pollution, everybody knows, is a very important issue of concern for the entire world. And due to rapid increase in industrialization, motorized transportation, and urbanization, this problem is becoming very, very severe. The entire urban areas in the country are very badly affected by the emissions from these sources, and air quality is very, very bad. And in India, the first concern started in late 1970s when an oil refinery, this Indian oil refinery at Mathura, was being set up, and there were apprehensions that this emission from this refinery would affect the beautiful white Taj Mahal, white marble in the Taj Mahal. And later on in 1970s, again, there were apprehensions of acid rains because of the industrial emissions from Rashtriya Chemical Fertilizer Plant. These two concerns were so high in the country that people were so much agitated that they put a lot of pressure on the government. And because of these pressures, the Air Act in 1981 was promulgated. And in this Air Act, an important requirement came that every industry would be required to emit only known quantity of emissions, pollutants in the atmosphere, and there will be limits and standards were set down for all the industries, and all were adhered, all were requested that you have to take consent to operate if you have to operate your industry in the country. But after this act, Government of India had initiated many actions and enacted many laws and acts, and have tried to do, I would say, a lot of work, but to restore and improve and protect the air quality in the country. But unfortunately, the results speak something else. The situation is really bad from worse. So I would like to just draw your attention to what were the challenges in 1980 and then in later part of the period. Next slide, Gopika. When this act came in 1981, and this act said that you have to take permissions from the pollution control boards to emit your emissions. So the immediate thing which industries experienced or faced, that they were not ready to initiate these monitorings because of non-availability of monitoring instruments. They were also constrained by the fact that there was no manpower, skilled and trained manpower available in the country. And more importantly, there was a belief in most of the small scale, medium scale, and even in some larger industries that they do not have any air pollution problem. There's no such big problem with us. And PCB staffs in different pollution control boards were very weak in inspections at that time. And community was also not very vigilant. Community used to express concern, but they did not have enough knowledge, or they were not able to put enough pressures on the industry to safeguard the or control the emissions and safeguard the impact on them. Then in the ambient air quality, which was the responsibility of the state and central government, we were slightly weak and there were flaws in planning and designing of air quality monitoring network. So, and there was also very low emphasis on monitoring of some of the critical pollutants. And there was almost no recognition that local meteorology also is playing a very, very important role in air quality management. So these were the issues and challenges which were confronting the country at that time. I'll take up these issues one by one and explain to you in more detail what were the issues. Next go figure. Okay, these are this I will take up. Go back, please. Yeah. So I'll take up these issues one by one. That about the monitoring instruments. So at that time, a general feeling was that all industrialized countries, especially USA, Japan, and West Germany, they had almost shifted from manual monitorings to automatic continuous recording measurements based on some physical, chemical, or electrochemical properties. Such instruments required very specific sensors for each pollutant, separate calibration procedures, needing calibration gases of exactly specified and known compositions, dust-free and air-conditioned environments for the keeping the main modules, and therefore it was felt that such systems will not be suitable for our country, and moreover these systems would be unaffordable right from the beginning because of the capital cost point of view, and then this will be very difficult to maintain in our Indian market, Indian conditions, because of non-availability of necessary calibration gases and availability of instrument spares. So it was felt that we have to look for some alternative. Then CPCB, where Dr. D.D. Agarwal was the member secretary, they looked at US-EPA and they found that US-EPA had developed very simple concepts for monitoring of source emissions and also of ambient air quality. And those concepts might have become obsolete in industrialized countries and they might have shifted to automated systems, but they still remained suitable for adoption in developing countries like India. And further, it was also realized that if we import such simple devices, simple design devices from foreign countries, they would be quite costly because there's a lot of complexities which are built into the system by the Western manufacturers, and therefore their cost also increases and their maintenance and upkeep also become difficult. Therefore, the most viable option at that time appeared to indigenously develop and produce our own simple monitoring systems based on these US-EPA concepts and at affordable cost. So that was the viable option which appeared before the country. And recognizing this need, a group of young professionals, in which I was also a part, decided to take up this challenge and try to develop this indigenous instruments in the country. Second issue is about the manpower. Industrial units, few in the beginning, but later on most of them built required monitoring infrastructures at their plants and tried to initiate monitorings. But there was a difficulty before them. Then where are the people? Where is the manpower who will carry out these monitorings? So some efforts were made by NIRI, some efforts were made by some academic institutions like IIT Kanpur. Then Envirotech got into this and tried to help the industries in these efforts. And as a startup, we started taking monitoring assignments rather than selling instruments. We thought that if we take up the monitoring assignments, then we ourselves will get trained. It also ourselves will get competency and experience, and side by side, industrial personnel will also get exposure, and they will also get trained. So this was a very great effort, which really helped to build the manpower in the country. The third very interesting constraint issue at that time was that most of the units believed that they have no air pollution problem. And most of the monitoring industries were interested just to obtain consents to operate and their renewals or reply to some complaints or questions rather than for evaluation or upgrading of performance on their pollution control systems. There was no really a great pressure either from regulatory agency, NGOs, communities, or self-conscience. So people were not willing on their own. Yes, we have to carry out these monitorings to make an assessment. How much are our emissions really, and how much we need to control it, and what kind of pollution control devices we have to install so that our emissions get reduced. Industries always kept on believing that there is no problem, and always did monitoring to show that there is no problem. And in such a situation, one can always, understand that there can be no improvement in such a situation. This was a very big issue, mindset issue at that time, that nobody was prepared to accept this, that yes, there is a problem. And further, smaller or medium scale industries, they always believe that they are causing none or very little pollution, and any reduction in their emissions shall also be very difficult and costly, and hence there is no purpose of monitoring. This was a very strange mindset in the smaller and medium scale industrial units, that they did not carry out the monitoring because they felt that it will be very difficult and costly, and their reduction will not improve the air quality. They always got their emissions monitored through a consulting agency, and the objective was very clear, that monitoring was being done when the plant was operating at very low loads and under conditions of causing lower emissions. So this was a mindset situation, which I am again trying to inform you, that this was a very difficult period, how to change this mindset. Therefore, whenever we used to discuss with them, we used to always tell them that, and we used to always made effort to make them recognize and accept that there is a problem, and this is how your emissions can be reduced. We tried to show emission when we took monitoring assignment. We did monitoring at in different conditions, in different load conditions, and whenever there was a different kind of suppose they had cyclones or multi-clones or ESPs or bag filters installed. So we used to show them before the pollution control device and after the pollution control device, and used to tell them that this is how your emissions can be controlled. Now you have reduced about 60%. There is a chance of improving it to 80%, 90%, 95%. And we always try to push them that you must do this monitoring yourself. Because if you engage an agency like us or somebody else, they will come for a short time. They will carry out the monitoring for the purpose you have invited them, just to get a monitoring report, which will get them consents. Your purpose will not be served. So you have to develop your regular self-monitoring infrastructure within your plant. Only then this objective of air pollution control would be fulfilled. Then I said weak inspections by the pollution control staff. there was one very strange phenomena which was noticed, that our board staff, they had come from academic institutions, and they also really had no experience in monitoring of source emissions or ambient air quality. So because they were not having enough scientific know-how, and not only of the stacks, but also vents and fugitive emissions and the practical aspects, and they were also not aware about the tricks often played by the polluters to reduce emissions. For example, industries always used to put an extra blower to dilute the air so that the concentration in the emission used to get reduced. So these are the different kind of tricks they used to play when monitorings were being done for in their industrial plants. And this pollution control board staff later on learned all these tricks slowly and slowly, and then impressed upon the polluters that they cannot hide or deceive the deceive the inspectors. So, but it was a process of evolution slowly and slowly. And in the beginning, all even some knowledgeable people, including like Professor G.D. Hall, they also got to be deceived that yes, we have no pollution problem. But slowly and slowly, everybody learned and took over this understanding of the tricks they were playing. Then a very important issue is of community. That if community around the plant is vigilant, and if they are aware what is happening and how much load or how much emissions they are receiving, so they had to put a lot of pressure on the industry. They had to go and sit on a dharna almost on the industry, but there were no such kind of pressures or vigilance by the community, and therefore industry used to get along, escape freely, and ultimately, if ambient air quality has to be improved, then pollution at source has to be reduced. And if you have to carry out monitorings in any industrial location, you have to involve the sort of industry along with you. Only with this consent, with this involvement, you can carry out that pollution monitoring. And that was becoming difficulty because industries were not allowing the community people to enter even their plants to see what is happening. And whatever pollution loads were being monitored or being observed, there was no system of sort of communicating this to the community either through a display board or through a broadcast, so that if that was happening, then some pressure would have been built on the industry, and industry would have taken a little more conscious decision. Yes, we cannot run away and we have to do this. Then next, in the ambient air quality, I mentioned three constraints that we were lacking in planning and design of air quality monitoring network. And here also we have to realize that the people who are designing this network, they have to understand that yes, there is a problem in the ambient air, and we have to assess its nature and magnitude in a very realistic manner. So our management planning and design of a air quality monitoring network have to be based on this. Yes, there is a problem, but we were not willing to accept at that time that ambient air quality has any issues. That is why we did not pay much attention to a very preparing detailed plan for siting of monitoring locations. This siting of monitoring locations is a very important issue, and most of the time, and I would say even today, sometimes we are failing in this, that we are not locating the monitoring station at the proper sites so that the real assessment of air quality could be made. And then we had to very cleverly or very clearly define what would be the frequency of monitoring. Suppose we have to do monitoring for 1 hour, 4 hour, 8 hour, 12 hour, 24 hour. That frequencies we were not able to very define clearly for different pollutants. and what kind of instrumentation should be adopted for monitoring different pollutants. So, and unfortunately, another thing happened at that time, that pollution control boards or the industries, the support of local bodies and civic bodies was not available anywhere. They always felt that this is not our area, this is the pollution control board problem or the problem of somebody else. Whereas civic bodies were very important. They had to take over, they should have taken over this responsibility of monitoring and then seeking the help of pollution control boards if they were facing any difficulty in monitoring. But that did not happen. This was one of the another difficulty at that time. Another difficulty which came in designing and planning of this air quality monitoring network was that we were not able to very clearly recognize the critical pollutants. The most critical pollutant in ambient air are those which critically affect the human health, and we laid emphasis on three pollutants at that time, mainly dust, TSP, and CO, and there were 5 parameters at that time. And whereas later on we realized that CO and ozone, these were two pollutants on whose short-term exposure very critically affect the human health, and that should have been immediately started monitoring. And if there was a difficulty in the availability of online analysis for them, we should have started with manual instrumentation only, and the data on this critical pollutants should have started getting generated. Then later on, when we developed the understanding in around 90 that respirable particulates are responsible for long-term health damage and increase in mortality and increase in the incidence of lung cancer, cardiovascular arrest. So many studies from the US and Europe and WHOs, they also revealed that even a small increment of 10 microgram per meter cube increases these incidences of lung cancer, cardiovascular diseases with a small increase in these concentrations. So this was a very important critical pollutant which we did not monitor till 1990s. Only started in 1990s. That last 1 decade, we had only monitored total suspended particulate in the atmosphere. Another important issue was about the importance of meteorology. Meteorology, particularly wind directions, wind speeds, mixing heights, and atmospheric turbulence oblique stability. They control dispersion of pollutants, and hence they are very essential in any air quality management plan. Therefore, these information on these four, I would say, wind speed, wind direction, mixing height, and stability, this should have been started or made mandatory at all industrial pockets and in all major urban areas. Because once this reliable information on this pollution loads, existing ambient air quality, local meteorology becomes available, then it would have been possible to assess local assimilation or carrying capacities of regional or local areas, and better development strategies and strategies for air quality management could have been developed. These were our weaknesses at that time, due to which we slightly failed, and our problems sort of grew of air quality, ambient air quality. Next, copy the next slide. This slide shows about 5 points, that what are the issues and challenges which are still confronting the country. what we are noticing is that a lot of talk is going in the media and newspapers, televisions, everywhere, that environment is important. We should pay attention to the environment. We should protect the environment. We should improve the air quality. But this is all for publicity. In really, nothing much is happening on the ground. Air quality is not improving. Why are we not able to improve the air quality anywhere, in any place in the country? It is still going from bad to worse. One of the reasons for this has been that we still have this tendency of copying the West with no consideration of our own culture and even environmental conditions. We have adopted Western technologies without making any suitable changes in them so that they become appropriate for our environment. We still blindly take the Western technologies as it is and try to use it in our efforts to protect the environment. We still depend upon Western measurement techniques and imported measuring instruments, making extensive or intensive monitoring of air quality too costly to be practical. We have to make it less costly so that more and more people can start monitoring and a lot of information becomes available. For example, we are still blindly following this approach of setting up continuous ambient air quality monitoring stations, which we all know that they are not made in India and too costly and difficult to calibrate and maintain. And we have collected large volume of data, because almost about 700-800 stations are now available in the country, and we have large volume of data from them, but we have miserably failed to utilize it and to correlate with the damages either on the human health or on property like Taj Mahal. And what is happening is that general public or community, especially the masses and workers, it is causing a mental apathy and disconcern for the cause of air quality among these. So we are really making it a very classy kind of a issue that okay, professionals or people who understand this or who are educated, they only will be sort of involved in this air quality management program, and masses and workers will not be involved in this program. So these are the issues which are still confronting us. Copy the next, please. Yes, this is a sort of presentation on how we started tackling this problem. First, we thought that let us gain insights of the problems. And we tried to gain insights in 4 areas. One is the instruments. So we felt that if we have to develop instruments for the Indian environmental conditions, we must understand what are the constraints. Constraints were irregular power supply, variations in voltage, frequency variations, and non-availability of earthings at monitoring locations, especially in rural and forested areas. So if you have to develop instrumentation, you have to be aware of all these constants, that these problems will be there in the field, and you must suitably modify your instruments or develop your instruments to take care of these issues of irregular power supply, variation, voltage, and all that. And second issue, which was noticed, that different parts of the country have different weather conditions, from extreme hot and humid to dry weather to extremely rainy conditions and cold conditions. So this instrumentation must work in all these weather conditions in the country, because we are not developing an instrument only for extreme hot or humid condition or dry weather. Their instrument must work in all these 4 conditions or make suitable, features or attachments along with the instrument so that they can work in these conditions. Then India, transportation of instrument is still a great difficulty because of rough terrains and not very good condition of roads. Now the road conditions have improved a lot, but still in rural areas or forested areas, we still have rough terrains, and there are a lot of difficulty in transportation of instruments, and instruments get damaged. And by the time they reach the site, sometimes they are not found to be not working because of that. So, next slide, Gopika. Secondly, about the manpower. What we noticed that in India, there are no formal trainings available to in any of the education institutes which are teaching environmental science as a subject. And in ITIs also, no facilities are there where people can be trained on use of instruments or monitoring of pollutants. In our opinion, industrial locations offer the best opportunity to get proper hands-on exposure and learning and training. But unfortunately, opportunities at these industrial units were shrinking and are still shrinking because industries gradually have stopped monitoring, and owners of the industrial units are not interested in building up this manpower. They are only interested in obtaining consents to operate and their annual renewals so that their operations continues uninterruptedly. So in such a situation, industrial locations are not available to provide training to the people because industrial personnel are not monitoring themselves. They are not getting trained, and whenever new person joins, the senior does not train him properly on the use of either instruments or use of monitoring techniques. So how does one get training? You cannot get training in a classroom. You cannot get training in a laboratory. So you have to have that industrial location where these trainings can be done. Therefore, in our opinion, the only viable option is that industries must start monitoring themselves or start realistic monitoring through the consultants and let them spend more time in monitoring pollution from their industrial units. Only then people will start training on this. We did our small effort that we took some industrial emission monitoring assignments from industries, and during these exercises, hundreds of people got trained in monitoring. And it would not be out of place to mention that some of those people really have educated or trained a number of other personnel in the country. That is how this manpower got developed in the country. Third, next, Gopika. We learned during our experiences that there were no budget for maintenance for the instruments. No industry provided any budget for upkeep of instruments or for trainings. No regular maintenance or replacement of worn out parts was carried out by the industry. If an instrument is out of order, it will remain out of order for a long period of time till some pressure is there on them to start using that instrument. And there was no sense of calibration and no even the mandatory requirement of calibration of instruments once in a year is not being adhered to. And so this was a very great difficulty. So looking at these insights, Envirotech set up a countrywide network of service personnel. They located people in different parts of the country who used to visit regularly industrial units and provide maintenance support and calibration to their instruments. And last, the most important part was awareness. This is, I think, a very critical issue, which we learned that most of the staff deployed for monitoring, they were never explained or briefed. Why are they doing this monitoring? What is the objective of monitoring? Is it for compliance? Is it for performance evaluation of a control system? Or you are doing monitoring to collect data for design of a pollution control system? This data is to be given to maybe some design agency. They want to get this data. Or You are doing this monitoring to understand the impact of your emissions on the surroundings, either on human health, surrounding agriculture, wildlife, or vegetation, etc. For what purpose are you doing this monitoring? Because unless and until this objective is very clear in the mind of the monitoring personnel, he will not be able to do justice to the monitoring or to the effort which he is making. He was also not aware that when he is doing monitoring in industrial emissions, he should have understood while monitoring that what are the process anomalies, are there any fuel variations, what is the different loads in the plant, or variation in the quality of raw material. All this will appear very clearly in the monitoring results. But he was not prepared, he was not told about all these things, so he never looked at the results, that if I am getting this different result, why I am getting this different result? What has happened? Is it because of the process anomaly? Is it because of the fuel variation? Or is it because of the load, less load or more load in the plant? Or is it because of the changes in the raw materials? He was not able to get any understanding because he was not analyzing the results. Similarly, if we have to understand emissions and its impact on the surroundings, we must investigate the toxicity of the emissions. And that for that, the analysis of constituents of the emissions is very important. So this information is very vital for the owner of the industrial units and as well as for the person who is doing the monitoring. Because unless and until such investigative information is available, the mind will not open up and the overall objective of air quality management will not take place. Similarly, the correlation of emissions with the local meteorology, understanding of the mixing height, what is available in that area, and its relationship with the strike heights. Because if that is not understood by the industrial, say environmental management of a manager of a industrial unit, he will not be able to plan air quality management in its surroundings properly. Another issue which we found that industries did nothing to create awareness among the surrounding population. They never told them about their industrial operation. They kept it quite a close secret, and they never community was never informed, or they were facts were hidden from the community on the importance of air quality. Because this is a very important issue, that if you are doing an air quality management effort, then you have to have an understanding of the importance of air quality. And this role would have been very well played by the industries. And if they had ensured that because of this awareness among the neighboring community, if their complaints would have reduced, then the pressure on them from the Pollution Control Board or regulatory agencies would have automatically reduced. So this is a very important step in air quality management, that industry must brief, must make surroundings aware about their industrial operations and also the importance of air quality. Next one, sir. Now I'm coming to some direct efforts which we made, Envirotech made, in the monitoring and management of air quality in country. As I mentioned that earlier, that we provided indigenous instruments to start with, because we felt that these instruments are very important. Availability of these instruments is very important, and unless the instruments are there, it will be very difficult, or it will be almost impossible to implement the Air Pollution Act in the country. So development of instrument was the first step which Envirotech did, and they produced indigenous instruments which were very simple in designs, very easy to operate and maintain in the field, and available at affordable cost. And these, you can say, in fact, were low cost instruments. Next one. After we developed this first instrument of stack monitoring, we put it on trial at the Indraprastha thermal power station for a very August gathering of chairman and member secretaries of several pollution control boards. And it's after a successful trial, some industries, also bigger industry like Indian Oil Corporation from Baroda, Shri Food and Fertilizer Factory at Delhi, they got interested and they purchased instruments and started monitoring. And this gave us a great flip that yes, this instrument will become very popular and useful for the country. And that is why we thought that let's use these instruments extensively in the field and see how they fare in how they operate in the field. So we took many assignments, and when we use these instruments on those monitoring assignments, we learned that these instruments require modifications. They require certain attachments so that a standard equipment with the help of accessories and attachments can be used in different environmental conditions. We noticed that in Thimble, we had a thimble holder design. So you see a sampling train in the sketch that there used to be three parts. One was a pitot tube, one was a thimble holder probe assembly, and one was a thermocouple. Three parts, which used to go into the stack to collect data. The thermocouple collected the temperature, pitot tube collected the flow, and thimble holder collected the dust or gas part of it. So filter thimbles were available in two sizes. Cellulose were available in 28 by 100 mm size, and fiberglass thimbles were available in 19 oblique 90 millimeter size. So in different, they were operable in different temperature conditions because cellulose was suitable only up to 100 degrees centigrade, and above 100 degrees centigrade, you have to use a glass fiber thimble. So we made suitable changes in thimble holder design in which both sides of thimble can be accommodated. So this learning came to us when we use these instruments in the field. So we modified the design of the thimble holder to accommodate two different sizes. And then somewhere we noticed that there's a lot of moisture in the flue gases. And if you collect a sample along with the moisture, it will get choke the filter paper and entire sample will be corrupted. So we introduced a heating system in the probe based on this feedback, and we developed a thermal heated probe system which kept the moisture at vaporized level, and we were able to collect samples properly. And we were doing stack monitoring. We also noticed that if you have to collect particulates and gases, and first if you have to collect only particulates first and then gases, it will take a lot of time. So we introduced a system that you can do simultaneous sampling of particulate matter and gaseous pollutants together. So this saved a lot of time and effort, and monitoring became more easy and convenient. Next one. Sometimes we noticed that there were many dust polluting industries, and when you inserted a probe with that filter holder, it used to get choked immediately. So we felt that the sample will not come in sufficient quantity. So what we did, we developed a small cyclonic attachment, which we put it before the thimble holder, and we used to collect bulk of the dust in this, and then on the filter thimbles. So this facilitated monitoring in the units where large dust was present. Later on, in some of the acid plants, there was a requirement for monitoring fluorides. So we developed Teflon impingers instead of glass impingers, so that otherwise fluorides react with the borosilicate glass. So we created these Teflon impingers. Then later on, CPCB gave a guidance on sampling of NOx. They indicated that NOx they suggested that it should be collected in a 2-liter chamber, and it is not possible to collect NOx in an impinger. So we developed a separate NOx collection assembly, and you can see the box specially designed for NOx. Similarly, for collection of CO, especially designed two-ended bottles was developed, where CO sample could be collected from the flue gas, which could be taken to an offset apparatus to do analysis of carbon monoxide present in the flue gases. When we were doing ambient air monitoring and we were laying emphasis on the wind monitoring, use of wind monitoring data, we noticed that whatever systems were available at that time, they were cumbersome strict chart recording systems. And since this information on wind speed, wind directions, wind local meteorology was required or almost on an hour-to-hour basis or even less than that. So this was a large volume of data. So we introduced data logging capabilities in the system, in wind monitoring system. This was done for the first time. That this data logging was introduced, and now the voluminous data on the local meteorology was available in the data logger, and this data logger also had facility to transfer this data to a PC, where we developed a software which could directly provide the sort of window diagrams and stability and information on horizontal stabilities. Next one. High volume samplers. You see the picture on the left hand side. There is a high volume sampler of about 4 feet, 3.5 to 4 feet height. This was very difficult to carry in the field because otherwise you require special vehicles. So, and high volume samplers were used to be kept wherever the pollution problem was to be assessed. So we developed a small, compact, lightweight system which could be easily carryable in a car dicky. And with the introduction of this compact model of high volume sample, the monitoring became more convenient, and a lot of consultants and pollution control boards, they started this compact device and started ambient air quality monitoring in the field very convenient. It has a gaseous sampling attachment also, and when we were doing gaseous sampling in those tubes in the impingers, we noticed that a lot of dust and moisture used to block these sort of inlet entries. So we introduced silica gel tubes right in the beginning so that the moisture and dust used to get arrested in them, and the dust, it was free from this moisture and dust. Gases used to get collected in the impingers conveniently and give us reliable results. In high volume samplers, another difficulty which we observed was that we were getting only carbon brush type of blowers that are made by KPT or Raleigh Wolf. So there were a lot of problems of replacement of those carbon brushes. So we developed brushless vacuum pumps and brushless motors, which we introduced in the system. And later on, when communities complained that there is a lot of noise of these blowers, we resorted to noiseless blowers, so that it was very comfortable for carrying out monitoring in the residential areas or around hospitals or in wildlife areas or forest. Next one. These were some improvements we made in the estimate based on the feedback which we received during our monitoring assignments. Then over next 2 decades, new and new demands came from the, I would say, community and regulators, that we need to monitor this, we need to monitor that also. An important requirement came in 1990s when it was recognized that respirable fraction of the dust is more harmful to the human health rather than TSP, and therefore we must measure respirable portion of the dust rather than the total TSP. So we took the help of scientists and engineers from the National Environmental Engineering Research Institute at Nagpur, and Dr. A.L. Agarwal was head of the air lab at that time. He developed a very unique device, a very small, compact cyclonic device, which was easy to install in a high volume sample. And this cyclonic device was introduced. And the beauty of this cyclonic device was that it was very small in size, and it did not increase the size of the instrument very much, and the instrument remained still very comfortable to carry in the field as compared to big bulky instruments which were made in the West by companies like Anderson and Tisch. They are still in use, but they are very bulky and sometimes very inconvenient to use them in the field. So this device, which really contributed a lot, significant lot in design. And two things happened with this, that a lot of confidence got developed in the country that yes, this is a well-designed cyclonic device, which is giving a correct assessment of the respirable dust. And if we use this device in the system, we will get a good assessment of the respirable dust. So this was a new development which we did along with the NIRI. And this is really the backbone of our measurement of PM10 or respirable dust in the country. Since 1992, when it started becoming popular, it's almost now 30 years. And this device is still being very prominently used in all locations. Next one. And the Motor Vehicle Act was sort of amended in 1990s also, in which emission monitoring from diesel-powered vehicles and petrol-powered vehicles was made mandatory. And it was made mandatory that you have to obtain PUC certificates, pollution and control certificates. And so what we thought that there was an instrument called Hartridge, which was available in UK, which was a very good device. And we almost copied that design and produced an indigenous version of that Hartridge design, and provided at almost 1/3 of the cost this as compared to Hartridge, and made monitoring of emissions from diesel powered vehicles very convenient. So this became a very popular instrument during the 90s and between 1990 and 2000. At that time, another important development took place in the world, that the Montreal Protocol was signed and CFCs were to be phased out. So we suggested that phasing out of CFC will take a lot of time. And till that time, why can't we have a recovery and recycling system? And so we introduced a recovery and recycling system that whatever CFCs were available, we can recover and recycle them and reuse them, and not release them to the atmosphere, so that their impact on reducing that ozone in the our atmosphere can be arrested. So this device also became very popular at that time, and a lot of people, especially the refrigerating companies, they started using this device. Next one, please. Personal exposures on workers became an important issue of concern, and people who are working in the mining areas or around the stone crushers or brick kilns or fugitive emission areas, they were getting exposed to high level of dust, and these workers were getting several kind of respiratory problems and diseases. So it was considered important that we must monitor the personal exposure on these workers, and we produced a personal sampler kind of a small device, which was a battery operated device, which used to be mounted on the body of the worker, and we used to collect a sample of the dust inhaled by him during that 8-hour or 6-hour or 10-hour shift of working. And then another device which we developed was a handy sampler, which we were able to put it into the work zone area and monitor the pollution levels in that work zone area and find out how much workers are exposed to different pollution levels in different areas of a work zone. So these two devices, they were both battery operated devices, and they were very extremely popular, and a lot of people got assessment of exposures on persons as well as on the work area environment. In 1996-97 period around, petrol was de-leaded and benzene was introduced as an anti-knocking compound. This resulted in the emergence of VOCs in the atmosphere, and so there was a need to monitor these VOCs, or especially benzene, because benzene was introduced. So we developed a small activated charcoal adsorption based device in which the gases could get adsorbed on the activated charcoal, and they could be dissolved and then analyzed in a GC to find out the concentration of VOCs. So this was a very simple device which immediately offered a solution to assess the level of VOCs in the ambient air. Next one. You see a monostatic sonar on the top, which I mentioned was in earlier slides and earlier talk also, that local metrology and assessment of mixing height is a very important issue. And when a lot of emphasis was being done on this, what we did is we took an assignment, unique assignment from in association with the Madhya Pradesh Pollution Control Board, from the industrial units of Rewa and Satna. There were a lot of cement plants in Rewa Satna area, and they were not getting consents to expand their capacities because there was a fear that they are already emitting a lot of emissions from their industrial units, and if they are allowed permission, they will again pollute the area much more. So a study was undertaken that let's find out whether their emissions are really contributing to the ground level concentrations. So a 2.5 year project was taken, in which we tried to assess the mixing heights in that area. And what we observed ultimately at the end of the study was that the mixing height in that areas were almost 60 meters to 90 meters of height. And chimney heights in most of the cement plants are more than 100 meters. So it was realized that these emissions from these cement plants are not likely to come to the ground because of the mixing height layer in between. And so the contribution in the ground level concentration in that area is not really because of this emission from the cement plant, but only from the local low emission sources. And this was such a important revelation that this study was accepted by the later on, we had a brainstorming session on this result of this study among the very elite professionals from the country, and they all agreed that yes, this is an important finding. And on one hand, the industry got a relief that they got permissions to expand their capacities, and the other, based on the scientific understanding, and on the other hand, the importance of mixing height was recognized, and this became mandatory in most of the EIA clearances that you have to develop, you have to measure the mixing heights. And so I think this was a very important this thing. And in this study, we also, for the first time, maybe validated a mathematical model to calculate the ground level concentration based on the model, and also doing simultaneous monitoring at several locations. And the results were found to very much in correlation with each other. So this was a very important sort of development which we took place, and in which Envirotech contributed a lot. Next one. In the beginning of this 21st century, another studies from UICPA and WHO emphasized the need to monitor fine particulates in the ambient air. They said that particle size below PM 2.5, below 2.5 micron is highly important, as it gets, it penetrates deep into our lungs and gets retained there, and it causes a lot of severe critical health issues. So US EPA developed a design for monitoring of PM 2.5 and put it on the public domain, and advised all the countries to adopt this design so that there is a uniformity in monitoring PM 2.5 particulates in the ambient air. So we, Envirotech, took this design from that public domain design and developed an indigenous sampler, which you are seeing in the photograph here. And we went to NIRI and we requested them to sort of do a compliance, whether it really complies with the US EPA design and is suitable for use in the Indian environmental conditions. So they, after a year-long study, they came to the conclusion that yes, this is as per the US EPA design and is suitable for use in our Indian environmental conditions. Next one, please. As I mentioned earlier, that CAQMS were required in the country because it was felt that weak concentrations of pollutants can be lethal, and communities must be alerted and informed about the critical periods during the day. Therefore, information on short-term concentrations or on hour-to-hour variations in the pollutants has to be collected and from the ambient air, and this required setting up of continuous ambient air quality stations. So we also felt that yes, it is time for us to change, and we wanted to get into this business. Then we made an assessment and we found that there are already 100 odd stations which have been set up in the country, but they are all lying inoperative. So we first tried to find out what were the reasons of their non-operativeness, and we came to the conclusion that there were some issues. That number one issue was that it was a belief that these are automated stations and require no manpower. So we came to the conclusion, yes, they are automated stations, but they still require day-to-day surveillance and maintenance and calibration. So we thought that let's take up this one assignment as a challenge and see whether we can operate this system and remove this myth that Indian scientists or professionals will not be able to operate this station because already 100 and odd stations are lying inoperative. So we took one assignment from Andhra Pradesh Pollution Control Board and set up this station, and we ensured that all the necessary spares and consumers were kept on the station itself, and we strictly followed the maintenance protocol given by the manufacturer and ensured that the station remains operational all the time. We posted a person on the station just to see what are the difficulties which are being observed and noticed, and I'm very happy to know in my mind that we were very satisfied that this station worked continuously for 3 years without a single day breakdown, and this helped us to build this confidence in the country that Indians or Indian are capable of operating these sophisticated instruments, and it is not difficult. So we did a lot of satisfactory, you can say self-satisfaction work on this stations. Next one. In the last decade, in 2010 to 2020, PM1, importance of ultra-fine particulate was getting recognized. So we went to IIT Kanpur and took the help of Professor Sk Gupta, who had designed a unique winds impactor kind of a impactor and gave us this technology to commercialize this manufacture of this instrument. And based on this technology transfer from IIT Kanpur, we produced this PM1 particulate sampler in 2015-16, and now more than 100 and 125 researchers in the country are using this sampler to collect valuable information on PM1 size of particles. And I believe CPCB and is already in the process of revising standards in next year, and I'm sure they will take notice of this valuable data on PM1 collected all over the country and use included as an important parameter in the air quality standards. Heavy metals. In 2009, our air quality standards were notified, and 4 heavy metals were notified in that. But unfortunately, we were not able to initiate monitorings because one reason that the concentrations were specified for annual averages. And it was desired because heavy metals are very small in quantities and their impacts are also noticeable over a long period of time. So it was sort of felt that their annual average concentration is to be calculated or measured. So if we have to use a high volume sampler or a respirable dust sampler, which normally operate for 24 hours, 28 hours at a time. So this means if you have to do an annual average of these heavy metals, and heavy metals can be analyzed by analyzing the dust collected on the filter paper, but you will have to collect almost 300 filter papers to arrive at annual average. We felt that if we develop a sampler which can run continuously for almost at least a month, then only 12 samples will be required to be analyzed and their concentration based on that 12 samples can be sort of assessed for annual averages. So we took the help of IIT Delhi and requested them to design a suitable system in which blower could be of that kind that it can run almost for 30, 35 days or 40 days. And so we introduced this sampler based on the design from IIT Delhi and introduced in fact 2 pumps in this, and in which what we did is that one pump used to operate for about 15 minutes, collect a sample for 15 minutes or half an hour and rest. The other sampler other pump will operate. So 2 pumps were simultaneously operating in tandem with each other and collecting the sample of the dust on the filter paper. So now we have used this sampler in coal belt area of Singrauli and Delhi, polluted areas of Delhi, and have learned that yes, heavy metals are present in appreciable quantities. So this means the detection of heavy metals has become possible, and I am sure that more and more people will start using this sampler to get an assessment of presence of heavy metals in the ambient air. Next one. Around 2015, and we got into a project with IIT Delhi and IIT Madras that the Government of India launched a Uchatar Avishkar Yojana, or especially for IITs, high-end educational research institutes, that you must do frontal technology development. And IIT Delhi and IIT Madras submitted a joint project to the Government of India, to the Ministry of Human Resource Development, for development of indigenous low-cost sensors, not systems, but low-cost sensors, so that for monitoring of PM 2.5, CO and NO2 in the ambient air. These sensors are still being imported from either UK or USA or Japan or China. And we felt that if India has to get into this low-cost sensor-based monitoring devices, then we must develop our own sensors. We cannot keep on depending upon these sensors purchased from either China or from Germany or from UK. So we started this project, and we are now at the sort of almost end of this project, and a very unique photographic sensor-based PM 2.5 sensor has been developed, which will not only give the concentration of PM 2.5, it will also provide you a picture of the size and shape of the particles. So this is a very important information about the shape of the particles, because the shape of the particles plays a very important role in assessment of health impacts on the human beings. So this is a good development which is taking place in the country, and I'm sure within a year's time we'll be able to commercialize this manufacture of these sensors and put it in the market for use by all manufacturers who wish to produce low-cost sensor-based systems in the country. Next one, please. Another unique development which we are doing is about the monitoring of odors. Now, what is happening is that due to urbanization, and development around industrial locations and also emergence of landfill sites for disposal of waste in the urban areas. Communities have been complaining of odors in their neighborhood, and there has been a great pressure and demand them that we must set up and control pollution, this monitor these odors and reduce these odors from these locations. So we found that in India there are no monitoring devices available for measurement of odors. In odors, 5-6 gases are very important, predominantly H2S, mercaptans, methanes, and a lot of pharmaceutical industries also give out a lot of substances which are very odorous in nature. So we went to with the signed an MOU with the IIT Jodhpur, in which we are jointly developing the sensors for monitoring odors in ambient air. What will happen is that the basic hardware will be same, and odor for sensors for monitoring H2S, mercaptans, methanes, they will be added from time to time and used in specific locations. So this will also be a very useful development for use in our country. So next one, please. I think I have got enough time, or I am running out of time. Okay. I'll quickly wind up.
Yeah.
I just wanted to brief you slightly about our contribution which we made in strengthening the scientific understanding and public awareness, which we always felt is very important. That is, scientific understanding and public awareness has to be created if we really want to make this air quality management successful in the country. So the first this slide in front of you can see this is our first Minister for Environment, Mr. Digvijay Singh Ji, with our Professor J.D. Agarwal, in one of the first exhibition organized on environment at Mumbai in 1983 or 84 period, I don't remember, but at that time. And this was a monitoring exercise which we kept on doing on stack emissions at several locations. Next one, please. So what we did is that whatever we learned during 80s and 90s and say in 2000, that was, I think 80 to 90 was a very great learning period for us. We learned a lot. We developed our competencies, we gained a lot of experience. So we shared all these experiences with the people, with the professionals, and wanted to get a feedback from them. We organized seminars, workshops, conferences, and training programs at different parts of the country in presence of various learned professors on various subjects, on EIAs, from laws, from general hands-on training programs, and things like that. Another slide, please. This is one we did one interesting seminar on understanding environmental laws right in 1986-87 period, in which a lot of Supreme Court judges participated. And we also felt that dust is a very major pollutant in the country. And we organized a scientific article contest basically on the importance of dust. And we received almost about 200 articles from different parts of the country. And out of them, we selected a few and published a book called Dusty Dawn, which contains those beautiful articles written by different people in the country. This book is available with us, and it's a very useful document. It was produced in 1995-96 period. We also went to neighboring countries to create importance on the air quality, importance of air quality and how to monitor and manage. We went to Nepal, we went to Sri Lanka, we went to Uganda, we went to Nigeria, we went to Zambia. I also went to Vancouver in an exhibition in a program organized by CII and met a lot of people there and tried to emphasize that Indians have the technical know-how, we have the capabilities, and to monitor our own air quality, emissions, and development of instrumentation. And we received a lot of encouragement from these countries, and we also did a lot of business in these countries out of this experience sharing. Next one, please. That is all what we contributed for the sort of in our efforts. And these are some suggestions which I have now come back. I've realized that if these suggestions are sort of introduced or accepted by the agencies or people, then air quality management would become better. First suggestion is that we must directly pressurize and empower all major and medium scale industrial units for self-monitoring of their emissions. There is no way escape from this. We should not accept avoidance of this, because this self-monitoring of their emission is a very, very important and key requirement if we have to build confidence and manpower in the country and understanding on our emissions and variations in our processes and other things. This is very important in the air quality management. This will build and let the owner of the industry know what is the exact situation in my unit. This can only be provided, this information can only be provided by their own staff. No outside consultant will be able to spend that much of time and provide them that report. So this self-monitoring is a very, very vital and important suggestion. Second, we must develop infrastructure and initiate regular air quality monitoring in all urban and industrial sectors, which fortunately is being done through under this NAMP program and initiated by government. And now I think under National Clean Air Program, this network is getting strengthened. But we must lay or stress emphasis on critical pollutants. Whatever we feel that these are critical, we must first identify what are the pollutants present in the air and then assess what are criticals out of that. At the moment, PM10, PM2.5, PM1, CO, VOCs, and ozone appear to be very, very critical pollutant, and we must ensure that these pollutants are monitored. I forgot to mention, I think the heavy metals are also very important because heavy metals are very carcinogenous and they impact, they create cancer in the bodies. Then third suggestion is that measurement of local meteorology, including mixing height at all major and urban and industrial locations, is very important. If we have this information of mixing heights, then I think the air pollution assimilation and carrying capacity studies can be initiated to help in development of urban planning and strategy for air quality management. I think these four small suggestions which I am putting forward for better air quality management in the country. There are some other suggestions which I will give you in the next slide. Next one, please. These are general and as a philosophical suggestions, and this is really from the point of view that our mind should change, our mental status should change. We must realize that our environment is unique and cannot be managed by or following or copying the West. We should be open to ideas and knowledge, but absolutely say to technologies or import of hardware, so far as the environmental management is concerned. We must accept ideas and knowledge, but we must develop our own technologies and we should develop our own hardware. Similarly, our criteria, indicators, and standards and limits should be all based on our local studies and relationship with actual impact on health, crops, structures, and ecology, etc. With no consideration of limits or standards accepted elsewhere. We should have our own considerations. In fact, each state in India and different regions of even the same state could have different limits depending on the local conditions and assimilation capacities. We are not working in this direction so far, but I think ultimately we'll have to shift toward this approach, that we'll have to have separate limits for different regions and for separate areas, different areas. And third is that communities should be involved in the monitoring and management of environment. It should not look or appear to be an administrative effort. We must involve communities. How? I think it's a question of a debate. A lot of things could be discussed on that, but this is one suggestion. And similarly, my firm belief is that indigenous instruments, hardware and technologies should be not only encouraged, but should be the primary factors in deciding our requirements, even if they do not meet the international standards in environment. In standards. In environment, we must appreciate law is the evolution and not revolution. It has to slowly evolve. We cannot create a revolution immediately. We cannot put stringent conditions and say that from tomorrow industry will start controlling their emissions up to that limit. That is why I said in the last slide, last point, that it is much better to have lenient regulations, requirements or standards, and comply with them strictly than to keep on threatening with stringent regulations, requirements, and overlooking or non-tolerating or tolerating the non-compliance. We should not tolerate non-compliance. That is why we should have slightly lenient regulations and requirements so that at least 100% compliance is ensured. So friends, let us be sincere and not try to fool the environment. I think this is going to be the most critical factor in air quality management, that we must be very practical and sincere in our approach. Next one, please. We would, as I said, continue our efforts to seek knowledge and support research wherever, everywhere, to develop newer techniques and instruments to monitor the environment, especially the air quality. We, especially I, seek your support and guidance in our endeavor. And I thank you all for giving me a very patient hearing to my thoughts on this issue. With this, I end here, and I'm open to questions from anywhere on any of the issues which I have discussed. Thank you very much once again, sir.
Yeah, thank you, Gupta ji, for the very useful and wonderful talk. You said you are not an academician, so actually, you are a professor of practice. So, we welcome to the academic committee because you do a lot of work. So there are some couple of questions, they're coming. So one of the question is, are there any instruments available in Envirotech as developed to measure, monitor indoor air quality?
Yes, we have developed small devices, and which we first, under the Sensor Air project, we got some know-how from you and others, and we prepared those devices and tried to use it on the ambient air or outdoor environment. There we noticed that there are a lot of problems because of the relative humidity and temperature variations in the atmosphere. So then we shifted them to indoor air quality, and we found that yes, in the indoor air quality, they are quite successful, and there are not much variation in the humidity and temperatures. So we are trying to promote those instruments. They are called APM 307 and 370. They are very much similar to what IIT Madras has developed devices, and I think these kind of small devices would be very useful, and people should start using these devices in the indoor air. They may be slightly costlier than the Chinese versions of them, but I think, as I said earlier, that our emphasis should be to use our Indian produced equipment, even if they are slightly costlier or slightly inaccurate. Only then confidence building will start. I think this can be provided to people.
Thank you. So, if participants who have any of you have any questions to Gupta ji, please use the chat box. Yeah, I have some questions. Maybe I thought I'll just get your wisdom
Right.
in addressing this various challenges the country, particularly the developing countries. So one of the challenges, all the developed countries, they have some technologies, and those technologies they will try to magnify in such a way that this is very important. For example, as you rightly said in the beginning, the air quality monitoring, continuous ambient air quality monitoring stations. Now there are a lot of investment going on that. So now, so in your view, uh, how this, particularly the developed countries, should address it? Because their one issue is we have to invest a lot on getting the accurate data, and hence some of the technologies may not be available in the country. And second, so how do we balance with the available local technologies in order to meet the requirement? Because health is important. So, in your experience in last more than 4 decades, you have learned through various journeys. So, what's your view on this one, sir?
Sir, I think you have raised a very important question, and it will open up a lot of venues. I think the important thing is that we have to start building this trust and confidence and relationship with the academic and research institutions. That relationship is still missing and not yet very strongly developed. And in this relationship, I think the regulatory regime in our country must also be a partner, maybe a silent partner in this, to give us the requirements and identify the requirements. And academics and research organizations in our country have got enough talent and to produce things and develop technologies. And Indian manufacturing industry is, of course, slightly weak, I would say, and they require a lot of innovations in their processes. Their mindsets have to change, and they have to accept that without improving or innovating new things, they are not going to sustain. And after all, the challenges are becoming important, and these new requirements which are emerging have to be met by somebody. And if we keep on saying that no, you still follow the old principles and old technologies, this is not going to work for a long time. But for example, this continuous ambient air quality monitoring station you just now mentioned, this started, thrust started in 2005. And since then, I have been trying very hard that we should develop these analyzers within our own country. Why are we not doing it? What is the hesitation? Why academic and research institutions are not coming up? And why government of India has so many schemes like this imprint or UAY or some other projects? Why funding is not an issue in this country today because of the availability of a lot of funds from SES and environmental SES and several activities. But I think this relationship, this forging of this alliance is not taking place between the industry and the academics. This has to, I think, we all have to sit down together and form this alliance and produce these things which are required in the country. Even if we start this project, say maybe in next 1 month, I think I'm sure within next 6 months to a year, we should be able to develop at least sensors or these analyzers. And once the analyzers are available, then setting up a station is not at all difficult. After all, in these stations, what we did is we bought analyzers from them. We did not even call them for maintenance and operations of these stations. We just bought analyzers from them. So we can produce our own analyzers in our country. And similarly for dust measurement, if we can have latest technologies like BAM, suppose if BAM is very good technology, then we should be able to develop a system based on beta attenuation technique. And we should be able to produce our own instruments in no time. But I think this forging of this alliance is not taking place. I think what is the block, I do not understand, but this is a block which is taking place.
Guptaji, one question is there. Is Envirotech developed any optical particle sizing instruments like a spectrophotometer to measure particle size and number concentration?
No, sir, we are still a small company and we do not have enough manpower and enough resources. So that is why we take the help of research institutions and academic institutions to help us in that development. We have the capabilities of producing this hardware once the prototypes are available. So we still believe that every industry, if they start manufacturing industry in the field of environment, if they start having in-house R&D, it will be difficult for them to develop newer instruments. They can improve the quality of hardware, they can improve and add attachments, but I don't think development of hardware as such would be easily possible without the help of academic and research institutions. So at the moment, we do not have these optical based systems, and we are looking forward to the guidance from regulatory agencies whether they do they need these kind of devices in the country and what for they need it. And if they are needed, then I think academic and research institutions should come forward that yes, we can develop a prototype, produce a prototype, and whatever investments are required, I think industry should be willing to come forward and offer that investment and assist the research institutions to develop it.
Yeah, Guptaji, Professor Bell Margaret Bell is there. I thought, Professor Bell, you can unmute and you can ask the question. I thought of instead of reading your chart, maybe you can please.
Yes, thank you very much indeed, Dr. Gupta. I really enjoyed that presentation. It was very interesting indeed. And I really
Sorry, I'm not
did
able to hear you properly, Margaret.
Pardon?
I'm not able to hear you properly. Can you be a bit louder, please?
Yes. Yes, I was just saying. Is that better?
Yes,
is that better?
It is audible. Yes. Now it's fine. Professor Bell, you can go ahead.
Okay.
Guptaji, can you hear me? Hear us, no? Yeah.
Yes.
Please, Professor Bell.
Yeah. Thanks very much indeed for that presentation. I really enjoyed it. It was very, very interesting. I agree entirely with the need to simultaneously monitoring meteorological conditions with pollution monitoring. But what sort of recommendations do you make for the location of the meteorological conditions census system with the pollutant monitoring cabin or network? You know, how many meteorological stations with respect to the number of actual pollution stations, the vicinity, how far away, etc.
Two important questions you have raised, I think. One is the location of the monitoring station. And that my suggestion would be that we must understand for whom are we monitoring. Are we trying to assess the health impact? And if we are trying to monitor the impact on the communities, then we must locate our monitoring station within or amongst that locality where people live, people are surrounding. If we keep our station away from them, then we are not really assessing the exposure on that community. So if we have to monitor the exposure on that community, we must place or identify the location of that station near or in between the community. And second question was regarding your meteorology part. And in my thinking or in my experience, we have noticed that because of urbanization, because of the tall buildings coming up different parts of the city, and because of the topography of the area also, a lot of wind patterns change from location to location. So we have to really do a reconnaissance of the survey, reconnaissance of the area first. And we see that if there are any hindrances to the movement of air, and if there are hindrances in the movement of air, then we must have meteorological monitoring sites at all those, which can identify the, hindrances. That if we monitor the local meteorology in one area, and if we have a hindrance on in between, then we go to the other side. So we should have two locations where we are measuring the local meteorology, because wind direction plays a very important role in affecting the communities of the pollutant load. So that wind direction more than the wind speed, I think, is very vital for any emission monitoring industry, that they must know in which direction their pollution is going. And therefore this wind direction, and in between suppose there are hindrances, then wind direction can change. And therefore it is very important that this every industry must have this wind direction information with them, and also the wind speed, so that they would know how far their emission would be able to reach. These are the two important considerations in the assessment of local meteorology.
Thanks very much indeed. Thank you.
Thank you. Thank you.
Thank you, Professor Bal, and thank you, Gupta ji. Gupta ji, I have one question, because there are many young researcher, young students, their young generation is attending our air quality management lecture series. So one of the things, because you have a BTech from IIT Kanpur, and then you went into an entrepreneur. So what is the message to the young students, particularly if, to take up this entrepreneurship as one of their ideas and pursue? Because most of them are comfortable, because I'm sure that entrepreneurship will bring more challenges, bring more innovative way of handling it. So what is your advice to them?
I think it is our culture that we always used to believe that son in the family will take up the work which father is doing, and nobody thought of taking up a job somewhere after education or graduation. So this was built into our culture, that we have to start our own, either manage the business of the father or grandfather, or start a new enterprise. Whenever a father used to have 4 sons, he always used to get different shops open for them, that okay, you manage this shop, you manage this shop. So they were never taught of taking jobs. They were always taught of taking up businesses, enterprises. They should manage your own enterprises. And I still remember the words of Dr. Kelkar, P.K. Kelkar, who was the first director of IIT Kanpur. When we were graduating, he said, boys, you are going out into the market now, and you are not going to become employees. You have to become employers. You have to create enterprises, because our responsibility lies in creating more enterprises, more jobs for the people. And we must create enterprises. And I think that is the message every youngster should develop in himself, that he has to do this job for the sake of learning, for the sake of getting experience. And after he gets experience and trained and does a lot of learning, then he must immediately start setting up a small enterprise of its own, where he can provide employment to 10 more people or 20 more people or 100 more people, depending upon the size of the enterprise. But I think that is the way to go forward in our country.
Yeah, Gupta ji, thank you very much. I think I hope at least a few will enlightened by your message, and take up entrepreneurship as their their career. There was one question, Gupta ji, regarding this LOCA sensor.
Yes.
So what is the views? What is your views on the use of this LOCA sensor for the compliance, regulatory compliance, and how is there any pilot studies you are being planned to get its confidence?
I think, Dr. Saab, these new technologies are always welcome, and we should not say no to any new technology or new innovation. We should always accept with an open mind. And only thing we have to see their efficacies and their suitability for our requirements. And I'm very confident that the communities will start using these low-cost sensor devices for making a first-hand assessment of the situation in their areas, because they will be really low cost devices ultimately if it happens. Although there is a very strong realization which is coming in these low cost sensors, that the sensors are to be replaced after every 6 months or every 9 months or after a year. And if this replacement cost becomes so high, then they will not remain really low cost, and people will start feeling a burden. What is this we have purchased, now we have to replace this sensor. So these are some, there are some issues in these low cost sensor devices. One is that why regulatory regime is not accepting them. Yes, that they have not been considered as a very stable and suitable for use in long term measurements. And secondly, there have been issues which have been identified by several users who have done experimental studies on them, that they do not give repetitive results, and they are so small, low flow rate, they operate on low flow rates that is it unthinkable that even a 2 square kilometer area or 2 kilometer by 2 kilometer area, will they be representative of that air quality in that area? So these are some of the issues that for what purpose are we going to use this? So I think for making a first-hand assessment of air quality or presence, or detecting the presence of any pollutant in that area, maybe these devices would be very suitable and very convenient, and they can be used as a supplementary devices along with our regulatory regime devices. Because one thing you should notice and observe, that in our air quality standards, they've all been drafted or created for the health impact assessment point of view. That 24-hour values or annual averages, or 4-hour or 8-hour values for CO and ozone, they have been prescribed in these standards, fully realizing that this is the minimum exposure required for making an assessment on the health. And if you do not measure pollutant at least up to this time limit, then you cannot make a realistic assessment on the health. So I think we should not compromise with this. Otherwise, we'll be going round and round and round. So if a learned community in the country has identified that these are the minimum exposures required, so we must adhere to this time being, unless and until a new revelation comes to our knowledge. So we should follow the CPCB air quality standards, in which they have also defined the technologies, and they have also suggested the instrumentation required for assessment of these pollutants. And if more pollutants are added, I'm sure CPCB will add technologies and instrumentation to that also, because CPCB alone does not do anything. It is the entire professional community in this country. I think there are about 20 to 30 members of that committee. They are taken from all walks of life, and they contribute very significantly. This is a very national document, which I think all Indians should take pride that this is our own document. Once that get developed, if these sensors are included in that, I think they will very wisely suggest for what purposes they should be used and they should be adopted.
Thank you, Gupta ji, for your wisdom of thoughts on various issues which you shared with the younger generation and also the experts working in this particular area of air quality management. Now it is time for us to go for one photo. So all of you, I request to start your camera. We'll have a pleasure of taking one photo with Gupta ji.
Yes, sir.
Sir, kariye chhod, yes. Okay. Dipankar Shah ji, could you please, all of you, just start your camera? Dheeraj, will you able to follow up?
Yes, sir. Those whose video is on, I can take the picture of.
Yeah, do it. Okay, good.
Okay. Everyone, please smile. Yes, sir. I've taken the picture.
Okay, thanks. So Gupta ji, on behalf of the entire research community, CEPHA network, air quality management association, IIT Madras. So entire fraternity of air quality management would like to thank you for your time and wonderfully explained your journey. I don't think so anybody having such an experience in air quality management, starting from like the last 4 decades. You've seen all the aspects of air quality changes over a period of time. Thank you very much, sir. So see
Thank
you
you, sir.
all in
Thank
the
you.
next air quality management series.
Thank you, sir.
Thank you.
Thank you.
Thank you. Bye-bye.